Hi, good morning students. This is Rohini Jasrotia from Army Public School Udhampur. Welcomes you in my next class for chapter Polynomials. Dear students, in this part we are going to deal with algebraic identities and various questions related to it. Dear students, let us start with the recapitulation part before discussing today's topic. And our today's topic is algebraic identities. Students, you can see that in previous class you have learnt about algebraic identities. I hope that you know what are algebraic identities and what does it mean. Let us see the definition of algebraic identities here. It says that an algebraic identity is an algebraic equation that is true for all variables in it. Okay, so algebraic equation or algebraic identity is that equation in which the value of any variable, I can say that the value of variable may be whatever you want to choose, the both had sides, like here LHS will always be equal to RHS in case you will put any value of variable. In the first session of polynomials I told you what a variable is, right? I told you that a variable is that particular thing which changes its values according to situations. So I am saying you that here if you will take any value of x and any value of y, you will always get x plus y whole square is equal to x square plus 2xy plus y square. Okay, so same is the case in identity too. I think you have read all these identity in your previous class, that is in your class 8th. So class, it is very simple that so algebraic identity is an equation in which if you will take any value of variable, you will always get that left hand side will be always equal to right hand side. Okay, so it is very simple. In third identity, what is it? It is x square minus y square. It means the square of first variable minus the square of first variable, it will always be equal to the product of x plus y and x minus y here, right? So in identity number 4, again it is says that if you have x plus a and x plus b, where a and b are any constant, you always get x square plus bracket a plus b of x plus ab. I hope that you know all these identities and you have practiced about these identities in your previous classes. So let us start with our main topic and the identities that we are going to discuss in this chapter. Okay, so let us see what it is saying. So let us move to our next part, that is algebraic identities. Students, let us discuss some more identities here. These are 1 2 3 4 4 identities are here that you are going to deal in this chapter, although in addition to the last 4 identities. Okay, so let us see here what is the first identity that I have taken here the sum of 3 variables. How many variables here? I have taken the sum of 3 variables here, that is x plus y plus z and after that whole square. So a trick to remember this identity is very simple. What you have to do, you have to square the first variable, then put the sign of addition, again square second variable, again put the sign of addition, and then third variable. So if you have to remember how this identity, what you have to do, if you have to take the sum of 3 variables and you have to find out their whole square, what you have to do, you will you will square the first variable, then put the sign plus, after that put the by second variable and square it, and so on to like this, and after that plus 2 into product of first and second term, plus 2 into product of second and third term, and plus 2 into product of third and first term. It's very simple. Now let us move to one of the important identity. It is your x plus y whole cube is equal to x cube plus y cube. Students, you have heard about the x plus y whole square or a plus b whole square, but this identity is new for you because here it is a cube. How you have to find the cube of polynomials, sorry, how you have to find the cube of variables? What you will do, will be like cube of first term plus cube of second term plus 3 into product of both the terms and in bracket the sum of both the terms. In the third identity, what I will do, I will just change the sign because I have to find the subtraction of both the variables and then their cube. Students, you also have to remember that always use Bodemas rule for simplification. So you have to use the bracket first, and after that you have to do the cube. Okay, fine. And last identity that is also new for you, it is like x cube plus y cube plus z cube minus 3xyz is equal to product of sum of first three terms, and after that product of first term square plus second term square plus third term square minus product of first two terms minus product of second third term and minus product of third and first term. I hope it is very simple to remember all these identity, and let us see how we are going to prove these identities. Students, let us start with your identity 5, that is why I have written it 5, because there are four identities that you have discussed in your previous class. That is why its number is 5 here. It is also given in your NCRT, you can see it there. Okay, so before starting the proof, I will tell you what I am going to do. I will take LHS, I will solve it and get a result that will be equivalent to your RHS. So let us see how I am going to do it. So students, let us take, it's very simple, let us take LHS first and start doing the question. So LHS will be equal to x plus y plus z square. You know that what does a square means? It means when I am multiplying a particular term with itself. So it must be x plus y plus z into x plus y plus z. Okay, after that what I am going to do, simple multiplication, x with x plus y plus z here plus y with x plus y plus z here and plus z again with the second term, that is x plus y plus z. I hope you know the simple multiplication here. So x and x will be x square plus xy plus xz plus xy plus y square. You know that I am multiplying y with y, so I am getting y square here. I am multiplying y with z, so I am getting yz here. Again I will get xz plus yz plus z square here. Okay, so after that I will see the common terms here. So I am watching here that I am observing here that actually x square is the only one term, so I will write x square here. After that y square is also the one term, y square here. Z square is also the one term, so z square here. Xy and xy are two terms here. Xy and xy are two terms here, so I will write 2xy, because you know that like terms will be added and unlike terms can't be added, right? So again I will find xz is also there, so I will write 2xz here. So right, xz and xz this. Yz is also two terms, so I will write here 2yz. So students, right, this is 2yz. Very simple. You can see that we have got RHS here, so I can write it here that LHS is equal to RHS. Very simple. This is how we have proved this identity. Okay. Students, let us start with your identity 5, that is why I have written it 5, because there are four identities that you have discussed in your previous class. That is why its number is 5 here. It is also given in your NCRT, you can see it there. Okay, so before starting the proof, I will tell you what I am going to do. I will take LHS, I will solve it and get a result that will be equivalent to your RHS. So let us see how I am going to do it. So students, let us take, it's very simple, let us take LHS first and start doing the question. So LHS will be equal to x plus y plus z square. You know that what does a square means? It means when I am multiplying a particular term with itself. So it must be x plus y plus z into x plus y plus z. Okay, after that what I am going to do, simple multiplication, x with x plus y plus z here plus y with x plus y plus z here and plus z again with the second term, that is x plus y plus z. I hope you know the simple multiplication here. So x and x will be x square plus xy plus xz plus xy plus y square. You know that y, I am multiplying y with y, so I am getting y square here. I am multiplying y with z, so I am getting yz here. Again I will get xz plus yz plus z square here. Okay, so after that I will see the common terms here. So I am watching here that I am observing here that actually x square is the only one term, so I will write x square here. After that y square is also the one term, y square here. Z square is also the one term, so z square here. Xy and xy are two terms here. Xy and xy are two terms here, so I will write 2xy, because you know that like terms will be added and unlike terms can't be added, right? So again I will find xz is also there, so I will write 2xz here. So right, xz and xz this. Yz is also two terms, so I will write here 2yz. So students, right, this is 2yz. Very simple. You can see that we have got RHS here, so I can write it here that LHS is equal to RHS. Very simple. This is how we have proved this identity. Okay. Students, let us see identity number 6. Again I will take LHS here, and after that I will multiply it 3 times. Why? Because here it is given that you have to do cube here. That's why I will multiply x plus y 3 times, and after that I will get the result. Again it is very simple. Let us see how I am going to do it. So what I am going to take, I will take LHS here, right? So your LHS will be here x plus y whole cube, right? So it will be your x plus y into x plus y into x plus y. Students, what I am going to do, I am again going to take simple multiplication here, but I will take two terms simultaneously, and after that the result I will multiply it with third term. Okay, so let us see here. So I will multiply x with x plus y, again y with x plus y, and here it is x plus y again, right? So let me multiply it with x into x will be x square, x into y will be xy, plus again it will be xy plus y square, and this will be your x plus y here. Students, you can see that xy and xy are same here, so I can write it here as x square plus 2xy plus y square, right? Because you know that like terms will be added here. So again it is the product of x plus y here, right? Okay, so what I'm going to do here, again there are three terms, there are two terms, and I will multiply these. Okay, so it will be x square, that is multiplied with x plus y here, plus 2xy, again it is multiplied with x plus y here, and again it is y square, so it is multiplied with x plus y again here. Okay, what you will get, you will get x cube plus x square y plus 2xy square plus, okay, you will get 2x square y here, sorry, you will get what you will get, you will get 2, students, here what you will get, you will get 2x square y plus 2xy square plus x y square plus y cube. Okay, students, you can see that here x cube is a similar single term, so I will write x cube here. Y cube is also the single term, so I will write y cube here. You are getting x square y and x square y here, and it is 3 times, so it will be 3x square y. Okay, so again I am getting this 3 times 2 and this, so I will get 3xy square here, students. But you will think that you have to prove this, so I can take common here. If I will take things common here, I can take 3xy common here, I will get the result here. Okay, so in the next step I will do that. Okay, what I'm going to do, we have reached where, we have reached here, that is x cube plus y cube plus 3x square plus 3xy square, right? In previous slide this is like this, So what I'm going to do, x cube plus y cube I will write same as it is, and I will take 3xy common in both the terms. So here I will get x and here I will get y here. This is RHS. So LHS is equal to RHS here, and you got the result. So always remember that x plus y whole cube is equal to x cube plus y cube plus 3xy bracket x plus y here, and it can be also equal to this result. So no need of panicking, you can use this result. Also you can use this result. Okay. Students, let us have a look at our identity 8. Here x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz and minus zx. Now we have to prove this identity. You know that how we can prove it. If we will prove that LHS is equal to RHS, then we can prove that this result is true. So students, we can't do anything for LHS as it is in simplified form. So we will take RHS first. Let me start here. Let me take RHS here. That is x plus y plus z here, and x square plus y square plus z square minus xy minus yz minus zx here. Now what I am going to do, I will multiply x with whole second term, that is x square plus y square plus z square minus xy minus yz minus zx. Right? After that I will multiply y with the whole term, that is x square plus y square plus z square minus xy minus yz minus zx here. Now again I will multiply z with the whole term, that is x square plus y square plus z square minus xy minus yz minus zx here. Okay, so let us start multiplying. X into x square will be x cube plus x into y square plus xz square minus x square y minus xyz plus minus x square z here. Now plus y into x square will be x square y plus y cube plus yz square minus xy square minus y square z minus xyz here. Now again plus x square z plus y square z plus z cube minus xyz minus yz square minus xz square. Now students, you can see that here you are getting so many terms, but let us see cubic form of x. X cube is the single term here, so let me write x cube first. Now xy square here, xy square plus xy square. Now let us find another term of xy. Here it is minus, so this and this will be cancelled. Now xz square, here xz square is of negative sign, so again this and this will be cancelled. Now x square y will be cancelled. Minus xyz and minus xyz and minus xyz here. So let me write here 3xyz, right? So I am getting y cube here, so I will write y cube. 1 z cube here, so I will write z cube here. Now x square z and x square z are of opposite sign, will get cancelled. Yz square will get cancelled. Y square z will get cancelled. So here you are left with only x cube plus y cube plus z cube minus 3xyz. This is equal to RHS. So RHS is equal to LHS, hence proved. Here let us practice part number 2. Any part, let me take part number 3 here. Okay, so I will do it for you. Very simple part. Here it is written that what, 3x plus 4 into 3x minus 5. Students, you can also see here that this 3x and 3x is common here. So again I am using identity x plus a into x plus b here, that is x plus a into x plus b is equal to what, that is x square plus a plus b x plus a b, right? Here x is your what, 3x, okay, a is your 4 and b is your minus 5. Okay, so what I'm going to do, let me take eraser here, let me write down equality here only. So x is equal to 3x. Now put the value here, it will be 3x square plus 4 minus 5 into 3x plus 4 into minus 5 here. So 3x square will be 9x square. 4 minus 5 will be minus 1, and minus 1 into 3x will be minus 3x, and it will be minus 20. Very simple, students. I have done 2 parts for you. Rest of the parts will be your homework. If you will come across any problem, you can ask me again. Here, students, let us see question number 2. Just have a look at what question is saying. Evaluate the following products without multiplying directly. It is very simple. What it is written here, what you have to do, you have to multiply both these terms, but here it is written that without multiplication. You have to get the answer. You have to get the answer, but without multiplication. Let us see how. Students, let me do first part for you. So here, first part is your, that is, yes, it will be your first part is your 103 into 107 here. Okay, students, shall I write here at 100 plus 3 and it as 100 plus 7? Yes, 100 plus 3 and 100 plus 7, right? So what I'm going to do, again I will use the formula of x plus a and x plus b here. Okay, so I know that you remembered it. It will be equal to x plus a into x plus b is equal to x square plus a plus b into x plus ab here, right? So in case of x, it is 100 here. So let me write 100 square plus 3 plus 7 into 100, right? Into 100 plus 3 into 7. Very simple, right? So 100 square will be 1 and 4 zeros. 3 to 7 will be 10, and 10 into 100 will be 1 and 3 zeros, right? And it is 21 here. So after adding, I will get 1 2 0 1 1. This will be your answer here. I think it's very simple, right? So students, you can also change 95 into 96 by 90 plus 5 and 90 plus 6, or 100 minus 5 and 100 minus 4. And the third part, you can also change it like 100 plus 4 and 100 minus 4. And in the same way, you have to do all these parts. I have done one part for you. If you will come across any problem, you can ask me. I'm telling you again and again, do solve these questions. Okay, you have to solve these questions in your notebook, and after that, if you will come across any problem, you can ask me. Dear students, now we have to solve question 4, and the question 4 is saying that factorize each of the following using suitable identities. Okay, so what you have to do here, students, you have to use a suitable identity here. Now let us see part number 1 here. Part number 1 is saying that here x plus 2y plus 4z whole square. You have to find what? You have to find x plus 2y plus 4z whole square. How many terms are there? There are 3 terms, right? So which formula we have to use? Which identity we have to use? We have to use a plus b plus c whole square, or x plus y plus z whole square identity. I hope you remembered the identity. So let us start here. So here it is written that, let me start the part 1 here. X plus 2y plus 4z square. Okay, so using identity, using which identity here? Using identity, which identity I told you? X plus y plus z whole square is equal to, okay, it will be x square plus y square plus z square plus 2xy plus 2yz plus 2xz, right? Now here your x is what? Here your x is x, here your y is 2y, and here your z is 4z. Now you just have to put the value here, so it will be your x square plus 2y square plus 4z square plus 2 into x into 2y plus 2 into 2y into 4z plus 2 into x into 4z here. So it will be x square will be x square, 2y square will be 4y square, 4z square will be 4 into 4 will be 16, and z square will be z square. So 2 into x will be 2x, and 2x into 2y will be your 4y here. So after that it will be 2 into 2 will be 4, 4 into 4 will be 16, and y into z will be yz, and at last 2 into 4 will be 8xz. So students, here this is the required answer here. Okay, so I can write it here as x plus 2y plus 4z whole square is equal to this, which is the required answer here. Okay, let us move to part number 2. In part number 2, what do you have to find? You have to find minus 2x plus 3y plus 2z whole square. Again using same identity. Fine, I am not writing identity here again. I will just write what is x here. Here x is equal to minus 2x, here y is equal to 3y, and z is equal to 2z. Now don't get confused students that here is minus sign. What we will do, you just have to use the same identity but keep your signs in consideration only. Okay, what do you have to do? You have to keep the signs in consideration. So I will apply here minus 2x square plus 3y square plus 2z square plus 2 into minus, you will also use minus here, minus 2x into 3y plus 2 into 3y into 2z plus 2 into minus 2x into 2z. You can also learn other identities also, or I can say that you can also remember other identities, but it is very simple to remember only one and change it according to the signs. Okay, so students, you can see that when I will take the sign of a negative thing, when I will take the square of a negative thing, I will always get positive. So minus 2x square will be 4x square, 3y square will be 9y square, and 2z square will be 4z square. Now here 2, here minus 2 and 3, so 2 into 2 will be 4, 4 into 3 will be 12, so sign is of minus 12xy here. Again here 2 into 3 will be 6, 6 and 2 will be 12, so sign will be 12yz here, and sign is the positive, y positive, because there is no negative sign here. Okay, at last what do you have to do? You have to multiply 2 into minus 2 will be minus 4, and minus 4 and 2 will be minus 8, so answer is minus 8xz here. Okay, so this is the required answer. This is the required answer here. Now students, let us see our part number 3. Here what is written? Here it is written that you have to find 1 by 4a minus 1 by 2b plus 1, and you have to find out the whole square here. Again there are 3 terms, so which formula you will use? You will use x plus y plus z whole square. Don't get confused that the coefficient is in fractions or here a, b instead of x, y. No need of taking tension, you just have to apply the formula there. Okay, and the formula is x plus y plus z whole square. Again I am not writing the identity, you will do it by yourself. So here x is your 1 by 4a, y is your minus 1 by 2b, and z is your 1 here. Okay, so again applying using identity, I will write it here using identity. Let me write down identity again. Okay, so using
identity what? X plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now just apply the formula here. So it will be your, what I'm going to write, I'm going equality here, it will be 1 by 4a whole square plus minus 1 by 2b square plus 1 square. Okay, after that now plus 2 into xy, 2 into 1 by 4a into minus 1 by 2b. Beta, you have to always use sign here. If sign is negative, you have to put it here. If sign is positive, you have to put it here. Okay, because it will create the difference in your answer. Now 2yz, so it will be 2 into minus 1 by 2b into 1 here, and 2zx will be 2 into 1 by 4a into 1 here. Okay, so let me solve it. 1 by 4 whole square will be 1 by 16a square. I told you the square of negative is always positive, so here it will be 1 by 4b square. 1 square will be 1 only, so 2 and this 2 will be cancelled. So I will use, what I will get here, minus 1 by 4ab. What I will get? Minus 1 by 4ab. Why? Because here the sign is negative. Again 2 and 2 will be cancelled here, so I will get minus b here. Now here 2 1s are 2 and 2 2s are 4, so what will you get here? You will get plus 1 by 2a. So students, this will be your answer, that is 1 by 16a square plus 1 by 4b square minus 1 by 4ab minus b plus 1 by twice, that is a. This is, students, let's move to exercise 2.5, question number 5 here. Here it is given that you have to factorize. Okay, so students, here this part is somewhat different from the previous question. 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. You have to factorize this. It means you have to find the factors of this. Students, let's count the number of terms here. There are how many terms? 1 2 3 4 5 6 terms. Okay, so if there are 6 terms, now you have to find out the factors. Students, I hope in the previous question you have seen identity, right? If I will say that identity, what was that identity? That was x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay students, now here students, you can see that this question is of the form of RHS. This question is of the form of RHS of this identity, and you have to find LHS here. What you have to find? LHS here. For this, what you can do, just have a look here. Can 4 be a square of any number? Yes, it is the square of 2. Can 9 be a square of any number? Yes, 3. Can 16? Yes, 4. So if I will use this, I will get this portion here. Okay, so let me try this. I can write it here as, I will start from here. I can write it here as 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz here. Okay, after this, shall I write here that 2x ka whole square plus 3y whole square plus 4z whole square plus, here I can write it here as 2 into, because I have to find the product of right, x and y, so 2 into 2x into 3y plus 2 into 3y into 4z and plus 2 into 4z into 2x. Okay students, I have written here. Now here a question comes in your mind that, ma'am, it is minus here, but you are putting plus here. So tell me how it is possible. So students, we just have to find out that which number, which x, a, y or z, from that which must be of negative sign, because we have to take minus here. So students, you can see that here this is the term that is the product of y and z term. Okay, this is the term that has the product of z and x term. So you can see that z is common here, right? So in rest of the term there is no negative sign, so it means that we have z as negative term. What we have z as negative term. That is why I will apply minus here and minus here. Okay, got it? Why I have written minus here? Because you have to use, or you have to answer, I can say that you have to get -1 and -1 here, minus and minus here, but according to identity I will get only plus here. But if I will put x, y or z any one as negative here, I will get my required answer. So you can see that this term is the product of y and z terms, this term is the product of x and z terms. So z and z is common here. It means z must be of which sign? Negative sign. Or you can also say that if y and x are of negative sign, you can also use that, but I will taking the one case only in which there is z is of negative sign. So what I will take? 2x plus 3y minus 4z whole square. I think you got it, how we have done this. Again I can write it here as like this: 2x plus 3y minus 4z. Again 2x plus 3y minus 4z. Why? Because you know that square means, so this must be your required answer. Students, let us move to part number 2. Here let me write part 2 here, that is 2x square plus y square plus 8z square minus 2 root 2xy plus 4 root 2yz minus 8xz here. Students, now just have a look here. 2, is 2 a square root of any number? No, right? 2 is not a square of any number. But if I will take root 2 into root 2, I will get 2 here. What I will get? 2 here. It means 2 is the square of root 2. What? 2 is the square of root 2. So I will use root 2 here. Now here comes the turn of 8. Is 8 the square of any number? So I can say no. But let me try. If I will take 2 into 2, I will get 4, right? If I will get root 2 into root 2, I will get 2. So if I will take all these in the combination, like 2 root 2 into 2 root 2, that is 2 into 2 will be 4 and root 2 into root 2 will be 2, that you will get 8 here. So students, you can see that 8 is the square of 2 root 2. What? I can say that 2 root 2 square is equal to 8 here. So I will use 2 root 2 in place of 8 here. So let us see how. So I am going to write root 2 x square plus y square plus 2 root 2 z whole square. Okay. After that again I will take the sign plus 2 into 2 into 2 root 2 x into y plus, here it will be 2 into y into 2 root 2 z plus 2 into 2 root 2 z into root 2 x here. Now students, you can see that 2 root 2 here, 2 root 2 xy, 2 into 2 will be 4, 4 into root 2 yz, this is the term. Now 2 into 2 will be 4 and root 2 into root 2 will be 2. So 4 into 2 will be 8 here. Now terms are matching here, right? So I will use, what I will get? Root 2x y and 2 root 2 z here. Now students, you will think that why I have left this space. I have left this space for putting the signs. Now you will tell me which sign I will put here. Okay, so how I will going to put it? You will tell me which sign I will put here. See students, you have minus here and minus here. This term is the combination of which? It is the combination of x and y term, and it is the combination of x and z term. So which term is common here? X and x. So I will put sign of minus with what? X here. So I will get here. You can also choose another option in which you can put y or z as negative. Okay, you will also get the same answer. So you can choose two options here. So I think I have chosen this one, so you can do it by yourself also. Students, we will find the answer for question number 6 here. Question is saying that write the following cube in expanded form. Here what you have to do, you have to find the cubes of these two parts. Students, in first part you can see that here it is plus sign and here it is minus sign. So you can see that here we will use two different identities for x plus y whole cube and x minus y whole cube. Now we will write it here as using identity. Which identity will we use? Using identity x plus y whole cube. Say it with me. But it will be x cube plus y cube plus 3xy into x plus y here. Now the next step is what you have to do. You have to write. You have to actually recognize which is x here. Here x is 2x and here y is 1. So let me write down, let me put the values in the identity here. So 2x cube plus 1 cube plus 3 into 2x into 1 into 2x plus 1 here. Now what is the cube of 2 here? 2 cube will be 8. So x cube, 1 cube is 1 only. So 3 into 2 will be 6x, and this is as such. Why 2x plus 1 is as such? Because these two are unlike terms. Which terms? These two are unlike terms. So 8x cube plus 1, 6x into 2x will be 12x square, and 6x into 1 will be 6x. So let me write it in the descending order. So it will be 8x cube plus 12x square plus 6x plus 1. Here this is the required answer. You can say that here twice x plus 1 cube is equal to this. Okay, very simple. Now let's move to next part. Here it is 2a minus 3b whole cube. Now again using identity, but I think you have cleared that which identity we will use. We will use here negative identity, that is x minus y whole cube. So signs will be changed and rest of it remains same. So it will be x cube minus y cube minus 3xy and x minus y here. Very simple. Again write it down. What is x here? Here x is equal to twice a, and here y is equal to minus 3b. Actually no need of writing minus here because we have considered it in the sign only. So if you are not considering the sign, then you can put minus here. If you will use this identity of plus here, so we'll use minus here. But if you will not use the identity of plus here, so you can use 3b only. Okay, got it. Now let's move here. So it will be your let me put the values. Twice a cube minus 3b cube minus 3 into twice a into 3b into twice a minus 3b here. So again it will be 8a cube, 3 cube will be 27, it will be b cube. Now 3 into 2 will be 6, 6 into 3 will be 18ab here, and again I will write twice a minus 3b. Why twice a minus 3b? Because these two are unlike terms. So 8a cube minus 27b cube minus 18 into 2 will be your 36ab plus minus and minus signs will be plus. So it will be your a square b here. So it will be your 54ab square. So I can write it here as twice a minus 3b whole cube is equal to